As you can see here, we are doing lab 2 part 1, whereby we need to prove this graph. When day is 1, I press 1 and clock is still 0, so I'm not pressing the button. And thus, from the LED module, it doesn't light up. So as you can see here, the graph says 0. So but when day is still 1, here, clock is 1, so I press 1, and thus LED lights up. As you can see here, the graph said prove it. So when D is still 1, but clock is 0, I'm not pressing the button, so it still lights up. As you can see here, it still 1. But when the D is 0, and then the clock is 0 as well, I'm not pressing it, but the output is still 1, as you can see here. But at this point, when D is 0, so I'm not pressing this button, but the clock is 1, so I'm pressing this button, it turns into 0, the output, as you can see here. But as for a while, as you can see here, when D is 1, for a while, for a short while, the output is still 0, because the clock is 0. But when the D is 0, so I'm not pressing it, so it's still 0 as well. But in the end of the process, when D is 1 and the clock is 1 as well, the output will be 1, as you can prove it in the graph. So that's it. Thank you. Very good morning. Here we have the circuit whereby pin number 3, which is the clock, is connected to the clock module, which provide as the input to this IC circuit. And from the D, it's connected to Q dash. And from the Q, which is act as the output, and the output is connected to the oscilloscope, whereby we'll be identifying the frequency and also the Vmax, voltage max. Here, this represents as the channel 1, which is the clock module, and this represents as channel 2, which is the output. And as you can see here, this is the frequency for the channel 1, and this is the frequency for the channel 2. And this is also the output frequency for the output of X, as we already obtained from the experiment. So, yeah.
Afternoon. This is the 74HC161, the 4-bit counter. As you can see, it's connected to a NAND gate here, and we use a counter this for the LED. So as you can see, when I press it, this is 2, this is 1, this is 3, this is 5, and then it goes back to 1. The 6 is not included because this when it doesn't include the run stop button. So when it comes to here, it reloads itself, and then it goes back to 1.
We are doing for Digital Electronics Lab E2 for part 4, which is basically also part 5, because the circuits of part 3 and part 4 are combined in this. And we're using 2 NAND gates and 2 NOR gates for the combination circuit, and 3 NAND gates for the read-only logic. Now this is to imitate a electronic die, so basically the image that's supposed to come out is in this fashion, in an order. So as you can see, it follows by 1, 2, 3, 4, 5 and 6, and resets again to 1. So it's basically simulating an electronic die. And yeah, as you can see, that's all. That's it.